Curdling, Chapter 6, Physical and Chemical Changes. Today is the second part of the same chapter. So, children, yesterday we studied about the nature of the physical change, where we found that when the when we tear the paper, it becomes smaller in size, but still it remains a paper. When we when we blow an inflated balloon in the air, it remains there for some time and then it deflates. Although the shape changes, but here no new substance is formed. Similarly, when we freeze water, it changes into ice. Ice is a solid state of water, but there is no change in the structure of the water molecule. So all these activities which we have done yesterday proved that within a physical change, no new substance is formed. Only few changes can be seen, and those changes are physically change, such as in size, shape, color, etc. And here again, I will give you one example. When sugar was mixed in water, the sugar dissolved in water and it gave a clear solution which tasted sweet. So this was also a physical change. The sugar is still present, but it was present in the dissolved state now. So we can get it back if we evaporate the water. Settling of the curd from the milk. Souring of the milk is a change. Stretching of the rubber band. So all these are also some of the changes which we came across, but yesterday we just studied about the physical change. But here on the screen you can see some of the changes are chemical changes also, such as your settling of the curd from the milk, souring of the milk. Because here what is happening? We are getting a new substance, and these are reversible change? No, these are not at all reversible change. Once they change, they cannot be back again. But if you go for dissolving sugar in water, if you go for stretching of the rubber band, these two are your physical changes. So one thing more which will be clear to you now, that when we are talking of a physical change, here no new substance is formed. The properties of the substance, it remains the same even when there is a change in the physical state. But sometimes we find that some of the physical changes are reversible, whereas some are irreversible. But when we talk of a chemical change, here exactly a new substance is formed. These substance cannot be reversed, and the property of the substance also changes. So today we will be talking about some of the chemical changes. And here when we are talking of a chemical change, I'll give you one example here. When we take a piece of paper now, and if we burn it, it turns into ashes. So as entirely a new substance with different chemical properties than the paper. Now the ash cannot be reversed to its original form, that is the paper. So what it is now? So it is now your chemical change. I was talking about the curdling of the milk. So what we happen over here? Here also we get a new substance, that is curd. And your milk and curd both are two different substances with different properties. That means here the chemical properties are also different. Once made curd cannot be reversed back into the milk. So here again you found that how these chemical changes are different from that of a physical change. Now children, as I was just giving you the examples that we have talked about yesterday, We will start with a topic that is rusting of iron. Children, you all might have seen in your day to day life, when you go out in the open, there are some pieces of iron, okay, which are left in the open for some time. So they turn brown. So this turning of these substances into brown is said to be rust. And the process is said to be rusting. Now we will talk more so that the topic is more clear to you. Some of these substances, the open, due to continuous exposure of the air to these substances which are made up of iron, they get flaky reddish brown layer develop on them. This flaky reddish brown layer is called as rust, and the process is said to be your rusting. But with the time, this layer of rust falls off, exposing to the inner surface of the iron, on which a new layer of the rust develops. And now what happens? Slowly and slowly, this metal iron on which this rust was developed, it eats away. Okay, and so it creates a major problem for such metals. So here you can see on the screen, you might have seen many of the vehicles in the junkyards, either in any of your motor shops, okay, where they mend the vehicles and all. If any of the old vehicle is there, okay, so what happens to that vehicle? It remains there for a longer period of time. So the part of the vehicle which is made up of iron, that is all covered with brown color now. So it is called as your rust has covered that metal, either that vehicle. Iron gates of your park, of your farmlands, even the benches of your garden, okay, almost every article of the iron which is kept in the open get rust. Okay, so these are some of the examples which you come across, either these are some of the substances which come across in your day-to-day life. Even at your home, you might have seen your shovels and your spade, and even sometimes your knife also. They get rusted when exposed to the atmosphere for some time. This is your bicycle, okay, the place where you have the, but it is of a machine, but in the same way you might have seen on which your cycle, okay, in your bicycles, all of you might have seen, if you don't properly oil it, what happens? You might have seen during the rainy season, basically it gets covered up with this brown substance, either you can say with this flaky reddish brown layer, okay, and this is what is your rust, and this is what is the process said to be rusting. So I hope all of you are clear with this now, what is rust. In the kitchen, you have your wet iron pan, which often gets rusted if it is left for a long time, either if it is not used for a longer time. So rust is not iron, it is different from that of iron on which it gets deposited. So rust is different, iron is different. Iron is a metal on which this rusting takes place. So children, as we are talking of the chemical change, we will be talking of one of the activity today, okay, where we are going to take a magnesium ribbon. So here you can see on your screen, we have a magnesium ribbon. It is found like this. It is, you can get it in your, when we come to the lab, I will show you, either when the school reopens, I will show you. This is how these magnesium ribbons look like. Okay, so what we are going to do in this activity now? We will take a small piece of this thin strip of ribbon of magnesium. We will clean it up with the sandpaper, and then we will bring it near to your candle. So here you can see when we are bringing it near the candle, what is happening. So when we bring it near the candle, it is, you can see it is turning up into, it burns with a brilliant white light. And when this completely burns, Now it will changing into ash. Okay, so here what happens, when it is completely burned, it leaves behind a powdery ash. So here you can see your magnesium ribbon that was there at the beginning and the ash. Are both of these two things the same? No. Does the ash look like the magnesium ribbon? No. Both of them are different now. Now you can see we got the ash. Now what we will do is, next we will put this ash in water. We will dissolve it in water. We will mix it with water. Will it dissolve? Let us see. Collect the ash and mix it with a small amount of water. And now we will mix it well. Now what we will do, we will test this mixture with the help of your blue and red litmus paper. I hope all of you remember, you have already seen those litmus paper. So here also you can see I have got it on your screen. One is your red litmus paper and the other one is your blue litmus paper. Now what we are doing, the ash that we have mixed up with the water, in that ash we are putting these litmus paper. So first we will put the blue and then we will put the red, and we will see if any changes are there within that. So does the mixture turns blue litmus red? No. When we are putting the blue litmus into this mixture, it is not changing its color. But now the mixture, when we are putting again into the mixture the red litmus now, so it changes to blue. So why it is happening? What does it indicates? On the basis of this test, okay, what conclusion do you get? Okay, what do you classify? What about the aqueous solution, whether this is acidic or basic? Already have studied in your acid and basic chapter also that if red litmus turns blue, that means it is basic, and if blue litmus turns red, that means it is acidic. So here what is happening? It is a basic, as it turns red litmus blue. On dissolving this ash in water, what we got? We got a new substance. What was that new substance? That new substance was your magnesium hydroxide. Because what was the ash? Ash was your magnesium and it got mixed up with water. So now what substance we got? We got magnesium hydroxide, which is a base. Okay, and now your magnesium oxide, again we got, that is a new substance. Okay, so how we are getting new substances? So magnesium oxide is a new substance which is formed on burning of magnesium. Okay, so when magnesium was burnt, okay, we got magnesium oxide. When magnesium oxide, that means the ash, it was mixed with water, at that time we got magnesium hydroxide. So here two substances, either you can say two different substances we got. Okay, so here another new substance was formed by mixing magnesium oxide with the water. So I hope it is clear to you now that in the beginning we had magnesium ribbon. When we put it on the candle, what happened? This changed up. This got converted into ash while giving a white brilliant spark. Okay, when it completely burnt, it changes into ash, and this is your magnesium oxide, which is a new substance. After that, what we did, we put that ash into the water. We mixed it with the water. So we got now magnesium hydroxide, okay, which is again a new substance. Now what we did in the next step, now we want to check it whether it is acidic in nature or it is basic in nature. So for that we have used the litmus paper, and when we used the litmus paper, what we found, there was no change in the blue litmus paper, but there was change in the red litmus paper, proving that magnesium hydroxide is a base. It is basic in nature. So children, I hope now you have understood about the rusting, as well as you have understood about the basic nature of your magnesium hydroxide. Or in other words, I just want to tell you how this chemical change takes place, how we get a new substance from a original substance. So here you found that from magnesium we got magnesium oxide, as well as we got magnesium hydroxide, and all these three have their own chemical properties. All these three substances are different, okay, and this experiment cannot be reversed again, okay, so it is a chemical change. So I hope it is clear to you. Now some question for you: what is rust and rusting? What kind of change is your rusting? And what are the essential conditions for rusting? I hope so it is clear to you. And Sairam, thank you.